Hello again, folks. Today we're going to touch and get into just a little bit brazing refrigeration copper. By brazing, I mean temperatures exceeding 1,000 degrees. Probably it'll take 12 to 1,500 to melt the material. And on refrigeration copper, copper oxide will form at those temperatures. We want to keep copper oxide outside the pipe, not on the inside. So in order to do that, we're going to keep an atmosphere of dry nitrogen in the piping system while we're brazing and for a little while afterward until it cools some. What I've got here is an inert gas regulator, and I'm going to zoom up on it some, and it's a flow control regulator, and you'll see here in a second. To braze piping this size, we want about 15 cubic feet per hour. Now I've already got the tank turned on, so we're going to go to this valve here, and there's a little ball in here that'll rise up, and right where my finger is the 15 mark. So we're going to open the valve, and you see the ball rise up. There's 10 cubic feet per hour. There's 15 cubic feet per hour. We're going to be brazing some 1 3/8 ACR copper, and that keeps the necessary flow. You want the presence of nitrogen in the piping plus a slight amount of flow just to make sure you don't lose the positive atmosphere of nitrogen. So that covers that. We'll move into brazing here in just a moment. Alright, what we've got rigged up here is I've taken a cap and drilled it and inserted my tubing into it that carries my nitrogen to keep my atmosphere in there. There's a joint we're going to make, just a coupling, and I capped the other end and drilled a hole in it just to make sure we have a good nitrogen rich atmosphere. I'm going to chuck it up in this vise, and we'll put some heat to it here in a moment. Now I'm using 15% silver filler rod. It's 80% copper, 15% silver, and 5% phosphorus. I believe that's what it is. But anyway, it's 15% silver solder, and that'll flow really good and make a good joint for us. But let me get everything set up here and we'll carry on. Alright folks, as you can see, I haven't made any special provisions on cleaning this piping. It's in pretty clean shape. It's newer. It's bright copper. The only real thing it has on it is the writing. This type of brazing lends itself to not needing a lot of cleaning. If you feel they need cleaned, clean them by all means. But this stuff here is clean enough that it won't require any. Now I'm going to move in with the torch here in just a moment, and I'm going to be heating this thing from all sides. I'm going to be heating from above, below, and it's a lengthy process, and it'll take me several minutes to get this joint made up. I'm using an acetylene torch, a B tank as we refer to it, acetylene only, and it makes so much racket I won't be able to make comments over it. So just bear with me here a moment and we'll show you how to braze this joint up. Alright, you can see by the color change on the pipe there's been some oxidation take place. It's copper oxide, and without the nitrogen all that would develop on the inside of the pipe and eventually break loose and get into our refrigeration system, be it a little heating cooling unit or some kind of super cold temp stuff. You'd have the potential to clog up orifices and all sorts of things. Alright, there it is. I sawed this piece in half just to show you the outside where we had no nitrogen atmosphere or nitrogen rich, and the inside where there was absence of oxidizing gases. You can actually see where the filler material pulled under the coupling into the joint. You can see the silver solder under there. So even though it looked a little sloppy, it was effective. And imagine all these copper oxides inside your refrigeration system. Just be a bad deal. This is just one final parting shot. I flattened it out and bent it over to show you that the brazing material ran all the way under the coupling. That's a pretty good solid leak-free joint, I'd say. Of course, we didn't pressure test this, but when you get that kind of penetration with your filler, I don't think there's much doubt in it.